A low Earth orbit is an Earth-centered orbit close to the planet, often specified as an orbital period of 128 minutes or less and an eccentricity less than 0.25. Most of the artificial objects in outer space are in LEO, with an altitude never more than about one-third of the radius of the Earth. The term, LEO region, is also used for the area of space below an altitude of 2,000 kilometers. Objects in orbits which pass through this area, even if they have an apogee further out, or are suborbital, are carefully tracked because they present a collision risk to the many satellites in LEO. All crewed space stations to date have been in LEO. From 1968 to 1972, the Apollo program's lunar mission sent humans beyond LEO. Since the end of the Apollo program, there have been no human spaceflights beyond LEO. A large variety of sources define LEO in terms of altitude. The altitude of an object in an elliptic orbit can vary significantly along the orbit. Even for circular orbits, the altitude above ground can vary by as much as 30 kilometers. For circular orbits, this in turn corresponds to an altitude of 2,042 kilometers above the mean radius of Earth, which is consistent with some of the upper altitude limits in some LEO definitions. The LEO region is defined by some sources as a region in space that LEO orbits occupy. Some highly elliptical orbits may pass through the LEO region near their lowest altitude. Suborbital objects can also reach the LEO region but are not in an LEO orbit because they re-enter the atmosphere. The distinction between LEO orbits and the LEO region is especially important for analysis of possible collisions between objects which may not themselves be in LEO but could collide with satellites or debris in LEO orbits. The mean orbital velocity needed to maintain a stable low Earth orbit is about 7.8 kilometers per second. And for 1,500 kilometers to the launch vehicle delta, we require to reach normal LEO orbital velocity of around 7.8 kilometers per second. The pull of gravity in LEO is only slightly less than on the Earth's surface. This is because the distance to LEO from the Earth's surface is much less than the Earth's radius. However, an object in orbit is, by definition, in free fall, since there is no force holding it up. As a result, objects in orbit, including people, experience a sense of weightlessness, even though they are not actually without weight. Objects in LEO encounter atmospheric drag from gases in the thermosphere. Objects in LEO orbit Earth between the denser part of the atmosphere and below the inner Van Allen radiation belt. Equatorial low Earth orbits orientation with respect to the Earth's rotation. Orbits with a very high inclination angle to the equator are usually called polar orbits. Higher orbits include medium Earth orbit. Orbits higher than low orbit can lead to early failure of electronic components due to intense radiation and charge accumulation. In 2017, very low Earth orbits began to be seen in regulatory filings. These orbits, below about 450 kilometers and referred to as VLEO, require the use of novel technologies for orbit raising because they operate in orbits that would ordinarily decay too soon to be economically useful. A low Earth orbit requires the lowest amount of energy for satellite placement. It provides high bandwidth and low communication latency. Satellites and space stations in LEO are more accessible for crew and servicing, since it requires less energy to place a satellite into a LEO. And a satellite there needs less powerful amplifiers for successful transmission. LEO is used for many communication applications, such as the Iridium phone system. Some communication satellites use much higher geostationary orbits and move at the same angular velocity as the Earth as to appear stationary above one location on the planet. Unlike geosynchronous satellites in LEO have a small field of view, only able to observe and communicate with a fraction of the Earth at a time. This means that a network of satellites is required in order to provide continuous coverage. Satellites in lower regions of LEO also suffer from fast orbital decay, requiring either periodic reboosting to maintain a stable orbit, or launching replacement satellites when old ones re-enter. The LEO environment is becoming congested with space debris because of the frequency of object launches. This has caused growing concern in recent years. since collisions at orbital velocities can easily be dangerous and even deadly. Collisions can produce even more space debris in the process, creating a domino effect known as Kessler syndrome. The Combined Space Operations Center, part of United States Strategic Command, tracks more than 8,500 objects larger than 10 centimeters in LEO. There could be approximately 1 million very dangerous objects larger than 2 millimeters, which are too small to be visible from Earth-based observatories, according to a limited Arecibo Observatory study. This article incorporates public domain material from websites or